All right? Volume. This is, again, how much space it takes up. Okay? That's volume. And the reason why we don't want to attach volume and mass together is because of this. Most of the time, if something takes up a lot of space, it's going to have a lot of mass. Okay? What do I mean by that? It would be simple. Okay? My devil. Who takes up more space? You or me? Me. Okay? So if we were to put us on a scale, who do you think would have more mass? You or me? Me. And that's why you connected the two by saying mass is how much space something takes up, right? But the whole issue here, though, is this, though. If I were to get a balloon, right, what is a balloon filled with? Air, helium, right? Gas, correct? All right? And so could we get a balloon that takes up more space than you? Yeah, because I could just blow it up, right? I could get a balloon that takes up more space than you, so it would have more volume than you, just like I have more volume than you. But if I put you on the scale, then I put the balloon on the scale, who's going to have more mass? You. You see what I'm saying? So that's why we don't want to use mass as how much space takes up, because sometimes that's true, but then sometimes it's not. All right? But volume is always how much space it takes up. Now, there are two ways to determine volume. All right? And it's in your notes. All right? So I want you to make sure we see those two things, because that's what we're trying to make sure we understand today. All right? If the volume is of a liquid, all right? If the volume is of a liquid, then what we usually do is we pour it into a device like a graduated cylinder, okay, or a beaker. Or if you're a child and you're trying to take medicine and we're trying to figure out how much medicine are you supposed to take, you'll put it into one of these little cups, right? These little cups here, this is basically a beaker. This is basically a graduated cylinder. All it does is it just says, I'm going to pour a liquid, and then it's scored to let you know how much liquid you put in here. Okay? So in this case, this is measured in milliliters. All right? So what I want you to know here is, if we're measuring something as a liquid, it's usually going to be measured in liters. All right? Because most of the time these things, they're scored to be in liters or milliliters. For example, you know, like I said, if you have one of these bottles that you get from the store, right? Those, there you go. What do you call this bottle? A 2-liter bottle, right? And so by, you describe it by actually saying what the volume is. So if somebody say, what's the volume of that 2-liter bottle? We'd say, well, it's 2 liters. So liters is measuring volume. It's got 2 liters. Okay? So that's a liquid. Now, of course, this bottle is smaller than that bottle. So we probably wouldn't call this one liters. We would probably call this one in the milliliters category. All right? As we see right here. Yep, 500 milliliters. That's how much water goes in this bottle. 500 milliliters. Okay? 1/4 of what's in that bottle. All right? 1/4 that's in that bottle. So, liters. So again, liters could be kiloliters. Liters could be milliliters. All right? But the whole point here is, when I'm measuring a liquid, I usually got to pour it into something that will tell me how much volume it takes up, how much space it takes up. All right? As opposed to, if you're measuring something that is a solid. All right? If you're trying to figure out how much space a solid takes up, like, for example, if I'm going to take this cube right here, all right, this cube in this cup, does it even go in the cup? So can I use the cup to figure out how much space the cube takes up? No. So therefore, there's another way we do that one. And this one here, you're probably familiar with it. It's called length times width times height. What was that called? Anybody remember? Well, I'll give you a clue. Hold on, I'll give you a clue. When you did length times width, that was called area, right? So here we got another principle. Except area is good for a flat surface, right? Is this cube flat? No. This has got 3 dimensions to it. So that's why we have to add that 3rd dimension to our little calculation here. We're not just doing length times width. We also got to add the height off the ground. Like a piece of paper is flat on your table. Length and width is all I got to worry about. But this cube is not flat on the table. I can also worry about the height. So that's why I need those 3 dimensions right there. So if I go length times width times height, then I can get a volume of a solid. My question, though, is this. So now we're reviewing something that we said about literally 5 minutes ago. Length. So what am I going to measure length in?
Meters.
Not in this class.
Meters.
Meters. So therefore, length is in meters. Why? Because length is a distance. Okay? What am I going to measure width in? Huh?
Meters.
Meters. Because width is a distance. So that's in meters. What do I measure height in?
Meters.
Meters. Right? Now somebody say we use feet, right? No, we're talking about in the SI system. See, remember, I'm trying to get you adjusted now away from the way you do it outside this room, the way they do it in a science room, science lab, in another country, right? Even in America, the scientists usually use the metric system. Okay? We measure this in meters. So my question is this. If I got meters times meters times meters, what do I get? Huh? If I get meters, some of you go, there ain't no numbers there. Then you ain't thinking like I need you to think. Sir? You get m to the third power. What is m to the third power also known as? M cubed, right? What is this called? A cube. Why? Because it's got a length, a width, and a height. Okay? That's why it's called m cubed. All right? When they say to the third power. So that's what we got right there. Everybody got it? Now, what's a smaller meter that I could use? Could use millimeters. Okay? What's another smaller one I could use?
Centimeter.
Centimeters. And what's the third smallest that I could use? Decimeters. All right? If I wanted a bigger meter, what would I use? Kilometers, right? So if I did kilometers times kilometers times kilometers, I'd get what? Km to the third power, km cubed, right? If I use centimeters times centimeters times centimeters, I get what? Cm cubed. Okay? Here's something you need to know. 1 milliliter is equal to 1 centimeter cubed. All right? You need to know that. So I'm letting you know. You might want to write that down. I don't know if it's on your paper or not. Okay? But you definitely need to know that 1 milliliter is equal to 1 centimeter cubed. Like, for example, I said it quickly, but I said, how many milliliters were in this bottle? 500 milliliters, right? So if I said, well, how many cubic centimeters are in this bottle? What would your answer be? 500. Okay? By the way, cubic centimeters, cubic centimeters. Okay? Or centimeters cubed. Same thing. All right? Sometimes you just may hear people say it a different kind of way, and they're saying the same thing. So I just want to make sure you don't look ignorant when somebody talks to you. All right? Any questions about how you get the volume? Because today you're going to try to, let me see, we're going to be trying to get you to do some volume stuff real quick. Just some simple stuff. Just some simple tasks. Mostly it's about you getting used to centimeters. All right? That's really what it is. Mostly in getting used to length times width times height. All right? So, now let's get to the main one of the day, which is density. And with that in mind, I need to give you, well, in the words of Tony Montana, say hello to your little friend. Okay? If you lose it, then it's up to you to go make a copy of your friend's or somebody else's. This is the only copy I'm giving you. This is called a reference sheet. Okay? This reference sheet has got a whole bunch of things that you don't got to memorize, as long as you got it. But if you don't got it, then I guess either you'll never know it or you will have to memorize it. This is the reference sheet that you will be given on your NC final exam. If you notice, on one side is the periodic table. Okay? We will never look at this side until the last 6 weeks. Okay? Flip it over. This side right here, especially the left side. The left side right here is going to be your best friend for the next 8 weeks. Okay? Because all those formulas are formulas that you don't have to memorize. But you got to know what you're looking at. All right? So, this reference sheet right here you're looking at, we're going to get introduced today to our first formula. The formula for density. Okay? And now when we do formulas, meaning when you are doing a problem that involves these formulas on the left side, I do a thing called the 3-step process. Okay? The 3-step process stands for, by the way, in your notes, wherever you're writing stuff, leave a space here. So I'm going to put a mark there, leave a space. But then down here, I'm going to do my 3-step process. Okay? My 3-step process is formula, variables, calculate. Okay? Formula, variables, calculate. Now, the advantage for formula, variables, calculate to you is this. If you choose to use the 3-step process of showing me what formula are you using, then you show me the listing of all the variables, and then you show me your calculation. If you choose to use the 3-step process, then you get partial credit for each one you do. So in the end, if your answer is wrong, you can still get credit for the parts that you got right. Okay? If you choose to not use the 3-step process because that's just too much work and you'd rather just do it your own way, right? You can do that. But then either your answer is all right or your answer is all wrong. Got it? You won't get any credit for any of the partial stuff that you did do. Okay? So you got a choice of the 3-step process. Now, real quick, density. When we talk about density we talk about is how squeezed or compressed the particles that make mass are. Okay? Remember we said everything's made of stuff? Right? Because all things have matter. So therefore all things have mass. Well, how squeezed together that stuff is, compressed, that determines density. All right? So here's going to be one of those things where we talked about, on your vocabulary sheet, we said there was 2 words, direct proportion and indirect proportion. Well, if we increase the compression, we increase the density. Okay? That's a direct proportion. Why? Because as one went up, the other went up. That's direct proportion. If one went up and one went down, that's called inverse proportion. So just so you need to get used to those 2 words, because we say them a lot in this room. Direct and inverse. Direct means if one goes up, the others go up. Inverse means if one goes up, the other goes down. Okay? So, are we good so far? Let me ask you a question. All right? First question. Don't answer it out loud. Think to yourself. All right? Don't whisper it. Don't say it. First question. What weighs more, a pound of feathers or a pound of gold? Don't say it out loud. Okay, giving you 10 seconds. All right? Deshanti. Pound of gold. Coburn. Neither. Why not?
They're both a pound.
They're both a pound. All right, there you go. Okay? Pound, pound. They both a pound, so which weighs more? Neither. They're both the same weight. All right, you probably heard that one at some point in your life, probably. All right, if not, then you learned it today. Okay? So what weighs more, a pound of feathers or a pound of gold? Neither weigh more. They're both a pound. That's kind of a trick question, correct? They're just trying to see if you pay attention to the word weight. Okay? This is not a trick question. So now my question is this. Which is more dense? A pound of feathers or a pound of gold? Okay? Think about that for 5 seconds. Which is more dense, a pound of feathers or a pound of gold? Eric. Gold. Keitlinger.
I'll say gold.
Donovan.
Gold.
Gold. All right. A pound of gold is more dense because, first of all, they all have the same pound, right? So then it becomes, well, which one takes up less space? Okay, let me say one again slower. Which one takes up less space? Pound of gold or a pound of feathers?
Gold.
Pound of gold. So ready? Here's your introduction to an inverse proportion. All right? Pound of gold takes up less space. Less. So it has more density. So notice, as my volume increased, my density would decrease. Or let's flip it the way I wrote it on the board. If my volume decreases, what happens to my density? It increases. That's an inverse relationship. That's inverse. Okay? So I just want to make sure we understand what we're looking at here. Are we good with a basic understanding of what density is? All right? Water has a density of 1. So therefore, anything with a density less than 1 floats. Anything with a density more than 1 sinks. And so therefore in medicine, because I used to practice medicine, right, we can learn a lot about your health and your diet based on whether your poop floats or sinks. Okay? If your poop floats, it's less dense than water. You know what's less dense than water? Fats, oils. That's why, if George and I were in the ocean, he's going to struggle. And I'm not. Because fat floats. You see? All I got to do is stick up my arms and legs and I'm floating. George ain't got much fat. So you know what he's got to do? He's got to keep treading water with his feet. And at some point, he's going to get tired. And then when he gets tired, he's going to drop. Because muscle is more dense. So therefore, muscle sinks. Fat floats. All right? Now, let's get to our formula. Look at your reference sheet. We're looking at the formula at the very, very bottom. Do you see it? It's the formula for density. It even says density in big bold letters right above it. Do you see it at the very, very bottom? Okay, so here we go. If on a test question you give me D equals M over V, then you get 1/3 credit. All right, just for giving me the formula. And the formula's on the sheet of paper. You didn't even have to memorize it. You get 1/3 credit. That's formula. Okay? Part 2 is variables. Now, for you to get the variables, we go back to the thing that I said about 25 minutes ago. You better know what we measure stuff in so that you know where it goes. Because if you don't know what we measure stuff in, you're going to put stuff in the wrong place. And that could be dangerous. Okay? So, here's the first thing. That right there, we already know. M stands for what? Mass. What do we measure mass in? Sir? Grams. It's on your notes. That's why I'm saying you might want to read some notes. Okay? So you better know that basically now, if you have a number and it's got a G after it, you know that's a mass because G stands for grams. 20 kg, kilograms, mass. 20 mg, milligrams, mass. 20 g, grams, that's a mass. If you don't remember that mass is measured in grams, then I could put a number right in front of you and you'd never even know it. Okay? Volume. We just said volume can be measured in 1 or 2 things. What are the 1 or 2 things we said we can measure volume in? Liters and cubic meters, right? So again, I'm going to put over here, we may see, usually I'm going to go right now and say this. I'm going to go with the most common things we're going to see in this course, okay? So it's either going to be milliliters or it's going to be centimeters cubed. Those are usually the most common that we would see. However, What do we see right here besides Eric's theorem off in space? We see L for liters. We see M for meters to the third power, right? So again, just realize there's going to be some variation of that. Density here, density, is mass divided by volume. So the unit for density is going to be whatever the mass unit is over whatever the volume unit is. So in this case, it could be, well, first of all, this stands for density. All right. So in this case, it could be grams over milliliters, or it could be grams over centimeters cubed. But now, I'm going to stress this to you today, so that way you cannot say you didn't know. The students that tend to be the strongest students in this class are the students that tend to memorize units and variables the best and the soonest. All right? Like I had a young lady last semester. I don't even think she could speak English. But she got an 80 in the 80s in my class because she remembered all these numbers. She remembered these units, right? So when she would look at a word problem, she may not even be able to read the word problem, but she was like 20G, that's mass. You know, she'd say, hey, look, 50 ml, that's liters. That's volume. Mass volume, that's got to be density because that's the only formula that's got mass and volume in it. Like she didn't have to read, she just had to identify. So that's why, again, the sooner you can know mass is measured in grams, volume is measured in milliliters, density is measured in grams over milliliters, then the better you're going to be. Because when I give you a word problem and you see numbers, right, you're going to be like 20 G. That's mass. Okay? You're going to be like 20 M. That's distance. All right? The sooner you're better at that, the better you'll be as a student. Calculate involves algebra. Okay? So now, some of you are terrible at algebra. So some of you are going to need this thing. It's called a triangle. All right? So in this case right here, the triangle for density looks like that. Now, what does that mean? It means this. If I'm solving for density, what am I doing according to the triangle with the mass and the volume? Mass over volume. So what am I doing mathematically? What button on the calculator am I going to hit? Divide. Okay? If I'm solving for mass, what am I doing with the density and the volume? I'm going to multiply. Okay? If I'm solving for volume, what am I doing with the mass and the density? I'm dividing. You see what I'm saying? Like that's what the triangle does. It helps take away the algebra part to it. But now look at your reference sheet. And look at it carefully. Do you see a triangle drawn on there? So, if you're going to need that, who's responsible for making sure you know that? You are. Okay? Because on my test, you'll get that reference sheet. But my reference sheet will be just as yours is right now. It won't have the triangle on it. It'll have the formula, but it won't have the triangle. Okay? Are we good? Let's take a look at a sample problem. Okay? So with that in mind, I'm going to go ahead and turn on this projector. I don't care if you want to write the problem or if you don't. It don't matter to me. It's kind of up to you. But we're going to do the three-step process. Okay, I'm going to have to probably do it over here on the side because the way the screen will be, it won't give me a lot of room. But you got the notes. Hopefully you've written down this stuff. Let's hope. What I can do right now is maybe just bump that over there like that. So I got a little bit more wiggle room. Okay? All right. Right now, this is the one I'm looking at. Okay, that's the problem I'm looking at. Don't worry, I'll read it in case you're blind. Okay, like if you're sitting too far back and you can't see. All right, first of all, there's already a typo that I see. This ain't my sheet. All right, now, it says, while digging in the backyard, you find an old coin. Its mass is 26.76 grams, and its volume is 3 centimeters cubed. The question now is this. Here's my question. What is the density? Okay. The reason why we want to know what is the density, see this table over here? See all them things listed? What are they giving you? They're giving you densities. So the only way you're going to know which one of these things it is by calculating the density. But if you don't know how to calculate the density, then you're going to be in a little bit of hurt. Right? So how do we calculate density again?
Matter over volume.
Density equals mass over volume. Okay? So my formula that I'm going to use is D equals M over V. Now, you ready? Here's how I'm doing this problem, which is how I suggest you do this problem. First thing I'm going to do is go over here and say, hey, look, there's a number. Okay? Like, you can write on your stuff. The only problem right now is at the end of the semester, or the NC final, it's on computer. Okay? But right now, get in the habit. There's another number. Okay? Because here's what I can tell you. On my test, that word ain't going to be there, and that word ain't going to be there. You see what I'm saying? Like there they told you the mass is this. There they told you the volume is this. I ain't going to tell you that. I'm just going to say, hey, you got a block of wood, 26 grams, 38 centimeters cubed. Right? You're going to have to know which one is which. So right now, 26.76 G. What do I measure in G? Mass. So now when I go over here to my variables, I'm going to go over here and I'm going to say D equals, M equals, V equals. I know the M is 26.76 G. All right? So now I know this. I need to look for the density or I need to look for the volume. Well, they give me this number right here. What does that number stand for? Volume. So I'm going to go 3 cm to the third power. Does everybody see that right now? All right? So notice all I did was I chose the formula. Then I started putting in my numbers. Do they give me a density in the problem? No. So you know what I'm going to do? I'm going to put an X. Because like in algebra, that's going to be my unknown variable. Okay? Now, I go to C for calculate. All right? And all I do, so notice here what I do. Notice my formula. D equals M over V, correct? Do I have a D? No. So what did I use for D? X equals M. Do I have an M? Yes, 26.76. Right? V. Do I have a V? Yes. So notice when you set it up, like when you plug in the numbers into the formula, notice it looks just like an algebra problem. Okay? So when you do that, what do you get?
8.9.
Okay, hold on. Density equals what?
8.92.
8.92. Okay. What's the unit going to be? Grams over centimeters cubed. Okay. That's the unit of measurement. And now here is why test number 1 for all of my classes will be so low. Okay. If you give me a number without a unit, I don't care if your number is perfect, you're wrong. You got it? Let me say that one more time. If you give me a number without a unit, you're wrong. If you give me a number with the wrong unit, you're wrong. Okay? Because, well, if I owe you that much money, but I give you that much money, are we good? What's the difference? It's 200. Do you see my point? Right? You'll be like, yeah, but, right? Well, guess what I'm going to say? I'm going to say the exact same thing. You're going to say, but I put 8.92. Yeah, but you didn't give me the right unit. Okay? Just like if I gave you 200 pennies, that's different than $200. Okay? That's why. It's the same thing. That's the way I look at it. All right? Are we good? My density was 8.92 grams over centimeters cubed. So what's my answer? Copper. What is the coin made of? That 8.92 copper. All right? But notice, you can't answer this question without getting that number. You see what I'm saying? Like somebody said, man, I knew it was copper. Yeah, but you knew it was copper just because you're trying to just think it out. Right? You know what I mean? But you didn't know, because if you can tell me 8.92, then I know you know. Otherwise, you were just kind of guessing. All right? Does anybody have any questions on that one? All right, then here's what I want you to do. we're going to do the one to the right. All right, I'll move the projector a little bit here. So this is the one we want to do right here. The one that says diamond. All right, you go ahead and set it up. Okay, let me give you a minute for you to go ahead and set it up. By the way, when I say set it up, I mean make sure, like I said, we got this formula, because it's the only formula right now we know. But then if I say your name, like if I were to say Jayla, what did you put for M equals? Have an answer. If I were to say Mandy, what did I put for V equals? Have an answer. All right, that's what I want to know. Oh. I think I'm good with my recording. Actually, I need to save it for the next one. All right. Kevin, what did you put here? Good job. Michaela, what am I putting here? Good. Somebody can still mess it up. Matthew, what am I putting here?
2 centimeters.
Oh crap, I got 2? Crap. I'm going to have to say the whole class what your name is. McNeil, what are we putting up here? Okay, 2 centimeters cubed. Alright, when we do our setup here, D equals 5.28 divided by 2. Alright, Holmes, what's the answer?
2.64 grams centimeters cubed.
Okay, 2.64 grams over centimeters cubed. Is that what you said?
Mm-hmm.
All right. So what did you find?
Oh, no.
I'll give you a clue. It'd be the only thing that's got 2.64 next to it. Quartz? All right. Right. Remember, you think you have found a diamond, and then you found quartz. Okay? Dang, you went from having $1,000 to like, maybe you got a 20. All right? Any questions on that one? Okay. Last one, and then I'm letting you do your work. That one right there. Okay? I'm going to give you a minute to get it set up. This requires a little bit of thought. All right, take a look at the board real fast. Okay? See what I did for volume? Like, see the volume here? Because here's the mistake you might make. Does that got a cubed? Does that got a cubed? So that means you can't use that one number as you want to. All right? If they gave you 3, what did they just give you? They just gave you length times width times height, right? What are you going to do with them 3 numbers? You're going to multiply them. So you can go 3 times 4 times 6. And what does that get you? 72 centimeters cubed. Okay? So that's the number I'm going to use in my problem. Does everybody see that? When they give you a length times width times height, you can't just plug them in there. You got to calculate them, and then you can go ahead and plug it in there. So then when I go over here to my C, I better just, right there, D equals 184.32 divided by 72. And now I'm really going to hurt your feelings after this one. Like, I can't hurt your feelings yet because they gave you a table, right? But right now, I don't care about the table. Matter of fact, ready? Right now, I don't care about the table. Then I'm going to turn off the projector. Okay? Jordan, please give me the answer you got.
2.56.
2.56? All right. Okay, grams over centimeters cubed. Can somebody tell me why he is still wrong? Can somebody tell me? Does anybody know why he's still wrong? It's not a trick question. He is wrong. Nobody knows? Not even Donovan? Okay. You ready? This is why this first test will be low. All right? How many significant figures in that number? How many?
Not 4.
5. How many in that one? So how many can my answer have? How many did he have? That made it wrong. Okay? Do you see what I'm saying? Like, this is where Monday comes back to haunt you again. All right? So now, I got to round this to how many significant figures? So what should the answer be? 2.6. So 2.6 grams over centimeters cubed. That is the answer. So on test number 1, which is on Tuesday next week, right? If Jordan gives me that, I'm going to be like, dang, he's still wrong. But here's the saving grace. You ready? But if he gave me that right there, he's going to get 2/3 credit. Because the only part he got wrong was this one. But if he didn't show me this, then because of that right there, he got nothing. So that's why I'm saying the 3-step process is to your benefit. Plus, the 3-step process lets me know exactly. Look, if you're getting all the questions wrong, if I look at your 3-step process, I know exactly where you're screwing up. And when I know exactly where you're screwing up, I know exactly what to fix. Crap. This ends up a recording of this video.